Today's lesson is sections 3.3, and today we're solving systems of inequalities. The previous sections, 3.1 and 3.2, we've been solving systems of equations using either the graphing method, substitution, or elimination. And the ultimate goal, the answer to those systems, if there was a solution, was an ordered pair. We were typically solving for x and y. And most of the time we just put our answer as an ordered pair. Well, for today, when we solve a system of inequalities, we are looking for a range of ordered pairs, not just one, but there'll be an infinite number in many cases to show all of the ordered pairs that make this particular system true. And to show all of those ordered pairs that make a system true, we're going to be shading the appropriate area between two boundary lines, or maybe between a boundary line and a V shape, which would be an absolute value inequality. So that's kind of a preview of what we're doing in section 3.3. Let me give you some examples. So the first thing that has to be done, of course, is we need to solve for y in both of these cases. So let's just start with the blue equation, inequality actually. And solving for y means we're going to subtract x from both sides. So we get y is less than or equal to negative x plus 6. So I'm going to go ahead and graph this boundary line, which is y equals negative x plus 6. There's my y-intercept, negative 1 slope. So with your straight edge, that's going to be a solid line going through those points. And there's the boundary line. And I'm going to give you an option for doing the shading. And I'll do it a little bit differently on the next example. But for this particular line that says less than, if we were to shade this proper side, it would be the underneath side. Less than means below the line. So I'm just drawing some lines here to indicate the correct side for less than. Okay, now let's work on the red inequality. Again, we're going to solve for y. Let's do that over here. So I'm going to add x to both sides. Negative 4y is less than x plus 8. And now I'm going to multiply both sides by negative 1/4. Don't forget that multiplying or dividing by a negative causes us to reverse the inequality. And I get negative 1/4 x minus 2. Okay, y-intercept of negative 2. Slope of negative 1/4 looks like this, up 1, left 4. Or you could do down 1 and right 4. This time it's going to be a dotted line. Okay, so here's my boundary line, and I'm going to do this shading in red. So the greater than side for this dotted line would be this way. Well, for solving a system of inequalities, I'm interested in where these two shadings converge. Where do they meet? And for this particular system, where these two shadings converge is in between. And so if you do go ahead and shade as you go, you do want to make sure that the solution is much darker. It should be the combination of these two shadings. So just make sure that you don't leave any doubt as to where the solution really is in this graph. All right. So even though I shaded down here lightly, and maybe you shaded up here lightly for the red, this needs to be emphasized as the two shadings coming together. It needs to be a darker shading. So that would be my answer for this first system. So let's just try another one. Here we have another inequality that needs to be solved for y. So solving for y, I'm going to get y is less than or equal to negative x plus 6. So I'm going to go up to 6 on the y-axis, another slope of negative 1. It's going to be another solid line. So there's the boundary line. Now let's work on the red. Solving for y, we're going to multiply by 1/4 on each side. And we get y is less than 1/4 x plus 2. There's my y-intercept of 2, slope of positive 1/4. And it's going to be a dotted line. Oh, thought I changed it, but I guess I didn't. Okay, so there's the boundary line. So this time, instead of shading as I go, I'm just going to wait, do both of the boundary lines, and then just think, where do these two shadings collide? Where do they come together? So I'm thinking less than for this black line. Less than would be below the line. And I'm also doing less than the red dotted line. So where those two shadings come together, below the red, and also below the black. Okay, so the two separate shadings would meet in this area, and that's going to represent my solution. Any ordered pair that I can pick from this shaded region will make both of these inequalities true. And there's more than we could ever count, so we're just going to indicate by shading. Okay, I just have one more example, and this is going to involve a system that contains a boundary line that'll have shading, and then we have this other V shape. Remember, absolute value creates a V shape. So let's solve this top inequality for y. Y is less than or equal to 2/5 x minus 1. I just multiplied by 1/5 on both sides. We'll go ahead and graph that boundary line. That's y-intercept of negative 1, slope of positive 2/5. All right, solid line. And so there's the boundary line, and when we do the shading, we're going to be shading above the line. That's greater than. Okay, now let's do this V shape. This is just a translation of the parent function y equals the absolute value of x, but it's shifting this parent function. That vertex is here. Remember this. It is got a vertex at the origin, but this says to shift or translate this V shape 3 places to the left. Okay, remember the h here is actually -3. So here's my V after it's been translated, and it's going to be a dotted V shape. Okay, now we got to do the shading. Let's think about where these would be shaded separately. We've already said for the blue line we're shading above, and for the red V, less than is below. So it's above and below. You can kind of get an idea that we're going to have shading that converges outside of the red V, while at the same time being above the blue line. So it basically kind of goes in between. Okay, so I'll let you decide. You might be used to just shading each one separately and then noticing where they come together, or maybe you're able to just wait and do all of the shading at once in the end. It really doesn't matter to me. Whatever you feel comfortable with is fine. So that's all I have in the way of examples. This is going to be a lot of your homework, just practicing finding the solutions to these systems of inequalities. I will say this, the first two problems in your homework, numbers 1 and 3, because you're doing the odds through 15, read the directions carefully. You're not graphing those. You're just going to take a given ordered pair, a number for x and a number for y. You're going to plug those numbers in for x and y, and you're trying to decide whether or not that ordered pair represents a solution. If it does, then it's going to make both of the inequalities in the system true. So your answer for numbers 1 and 3 will just be yes or no. You need to test the ordered pair, and if it should happen to make one of the inequalities true and not the other one, then it's not a solution. So just wanted to give you a heads up there, because some people end up graphing those, and numbers 1 and 3 do not need to be graphed. You'll start graphing with number 5. So I hope this helps. You're always welcome to see me for extra help if you have questions, and we'll check these out next time.